Welcome to Ask and Learn.
So for this problem, we have the length of wire, we have the resistivity of copper and aluminum, the diameter of the wire, and the maximum current going through the wire. So the first thing you want to do for part A is to find the resistance of the copper wire. So we want to use R is equal to the resistivity times the length over the area. So pi times diameter over 2 squared. And so here the resistance is equal to about 5.15 times 10 to the negative 3 ohms. Now we can use that resistance to find the power. So we have P equals the current squared times R. We already know the current is 20 amps, and we just found the resistance. So here the power is 2 watts. Now for part B, we're going to do the same thing, but we're going to use the different resistivity. We're going to use the resistivity of aluminum instead of copper. So we'll take R is equal to the resistivity of copper times the length over the area. So pi times d over 2 squared. And that's going to be equal to about 8.5 times 10 to the negative 3 ohms. And then we're going to do the same thing as before. Power is equal to I squared times this new value of R. So the new power is equal to about 3.4 watts. So the power when using aluminum is higher than the power when using copper. So for part C, using the copper wire is safer because lower power means lower temperatures and a smaller chance of starting a fire.